Hey, welcome everybody. I'm David Venable, and I'm happy to be talking today about how we can expand ingestion capabilities in OpenSearch, specifically using Data Prepper. Thanks for coming. I'm really happy to be starting up the second half of today. We've got a lot of great sessions so far, and I'm happy y'all are here joining me today. I am a senior software engineer at Amazon Web Services working in search services. I'm also a maintainer on the Data Prepper project, which is part of OpenSearch. And before I joined Amazon, I was working at a small startup company, and we were working on mobile learning. We had a couple problems on our iOS team. The two problems we had were, one, we had a lot of difficulty with package management. And the second was we had a lot of problems reproducing builds. Our team was discussing about how to solve these problems, and these were the early days of iOS development. And so we were looking at building some custom solutions to do this. I really didn't want to do that, and a few of my colleagues also didn't want to do that. And so what we ended up doing was a little bit of research, and I came across a couple projects. One was CocoaPods, which was a very new project at the time. Now it's a really great package manager for Swift applications. And then I also had experience with Jenkins, which is an open source build system. And I found that Jenkins had a lot of plugins that were being developed to support iOS development. So I went and I talked to the team about these options, and we had a lot of good discussions and some valid concerns related to the solutions didn't solve everything we needed. So what I did was I contributed back to the community. I found how to add those features, I created PRs, and we got to use both those systems in our application, and they really helped our development and allowed us to focus on creating features for our customers. I joined Amazon and we started the OpenSearch project, and one of the things I've really loved is that we love to take in community feedback. We love to get community contributions. And I believe that data ingestion is a great area for community contributions. And so I want to tell y'all about how y'all can contribute to improving data ingestion in OpenSearch. First, what are some of the challenges we have when we ingest data? Well, one of the big ones is data quality. We want to be sure that when we get data into OpenSearch, it's in a good format. It's something that we can readily query and uses the right types. We solve this in Data Prepper through a set of processors that allow you to mutate and enrich your data. Another issue is privacy. So we know we have a lot of data coming in that has information that we need to keep sensitive. Social security numbers, email addresses, credit cards, all of these things we want to be able to remove out of our data. And then there's the problem of retrieving data in the first place. How are you getting it into OpenSearch? This is a big problem, and there are so many different ways you can get data. And this is why I think community contributions is a great area. Now, for all these reasons and more, the OpenSearch project has Data Prepper as the suggested ingestion tool. And so Data Prepper sits in front of OpenSearch, and you can ingest data into OpenSearch using Data Prepper as a separate application. Now, we support two basic modes of ingestion. The first is going to be pushed-based. So in this case, Data Prepper spins up a server, and you can have clients such as OpenTelemetry Collector or the Fluent Bit Collector sending data to Data Prepper. We also have a pull-based model. And in this scheme, Data Prepper will run and it'll reach out to external services to get data. A great example of this is Apache Kafka. So Data Prepper can read off Apache Kafka topics, get that data, and then push it to OpenSearch. We also support S3 as a source. And another really great solution we have is the ability to do database searches on databases such as Amazon DynamoDB or MongoDB. Two of my colleagues, Taylor Gray and Dinu John, gave a great presentation on this. I'm not going to talk too much about it, but it was before lunch. If you didn't see it, I really encourage you to watch the video on that. I want to explain how Data Prepper works internally. So Data Prepper really is a mechanism for creating pipelines. And we can see that our pipeline starts with a source. That source gets data into the buffer. Data then flows through processors to the sink. And so the external source is where we're getting data. Again, that's the OpenTelemetry collector, Kafka, whatever it might be in your situation. Typically, your sink is going to be your OpenSearch cluster. So how can you contribute to improving data ingestion? Well, you can contribute to some of the core concepts within Data Prepper, such as pipeline management. I'm actually not going to talk too much about that. I'm going to focus on a couple other ways. And that is, one, creating new sources. The number of sources out there is just too many for the maintainers to handle. So you can contribute with a new source for getting your data. And then also new processors. Different people have different needs for their transformations. And while we already have a great set of processors, there's always a situation that comes up where we don't always support it. You can create new sinks. I'm also not going to spend much time here, or really any time, because our goal here is to send to OpenSearch. But it is an option if you want to use Data Prepper for other sinks. And then, of course, you can also improve the existing plugins that we have. Understanding how Data Prepper plugins work and how you would write one will give you some of the knowledge you could use to make those improvements. Data Prepper is a part of the OpenSearch project, and it's Apache 2.0 licensed. So you can contribute to it and know that your contributions are part of the open source community. It is currently a single GitHub repository. I have the URL up there. And so everything we do in Data Prepper goes into that repository. The core components, the plugins, we have it all in there right now. It is a Java application. So Data Prepper core is written in Java. The plugins are written in Java. And then we also have a Gradle build. So again, Java and Gradle, those should be familiar to anyone who's worked on OpenSearch core before. Same technology stack. We do have our build as a multi-module to facilitate good logical dependencies between the different components within Data Prepper. That also helps us to simplify some parts of the build. Now I want to dive deeper into the project structure that we have in Data Prepper. First of all, I like to think of Data Prepper as having three basic components. The first one is Data Prepper core. This is the code that's responsible for parsing our YAML configurations, generating the pipelines. It's the code that handles initialization. We have a concept for plugins, and that's what we're going to talk about some. So the basic plugin framework is part of this core project. We have an expression language that people can use, and you can make use of without having to worry about the syntax as a plugin author. And we support an event model. Data Prepper plugins is the second major component within Data Prepper. These are where we have all the different plugin implementations. And going back to that Gradle multi-module build, typically any plugin will have a single project within Gradle. You might combine some. For example, our OpenSearch project has both the source and the sink. So if you write a plugin, how do you get it to work within core? Well, the third component is Data Prepper API. This is a set of module, or really a set of libraries or small classes and interfaces. So we have common interfaces that all the plugins will need to implement in order to communicate and get data into Data Prepper core. Up here, we have a sample pipeline configuration. What it's doing probably isn't too important, and I did cut out some of the details for brevity. But our pipeline starts with the source. This is Kafka. And then we go through a couple of processors. We have a CSV processor and then a GeoIP processor for geolocation enrichment. Finally, we send to the OpenSearch sink. This Kafka source is defined as a plugin. And so just like our team wrote the Kafka source as a plugin, you could also write your own source and make it available in this YAML that our pipeline authors use. The CSV and GeoIP processors are also plugins. And then finally, OpenSearch is a sink plugin. So right now, we're going to zoom a little bit just into that CSV part. We're going to take a little bit of a look at how this all maps. So if you want to create a new processor, say the CSV processor, you're going to create a Java class, and you're going to annotate it with Data Prepper plugin. We provide a little bit of metadata here so that you don't have to do a whole lot of coding. You just provide this metadata, and the core plugin framework will take care of mapping this into the YAML. So for example, we give it a name CSV. This is exactly what maps into the YAML file. And so you can define your plugin names. We know it's a processor and that it goes in this processor chain because we've declared the type to be a processor type. And then we also see some configuration. Source and delimiter, these are configurations you can provide. In the case of CSV, the source would be like, where are we getting this field? Delimiter would typically be comma, but just for the example, I used a hash sign. We wanted to make it really easy to create plugins and plugin configurations. And so we actually made this all available as Java classes. So you really express your configuration as a Java class. And so we can see that here. The CSV processor config will have all the configuration that we need for this plugin. We'll look at that next. That class that we just defined, CSV processor config, is, in this example, just shows 2 strings. So we have this string source, which maps exactly to the name we see in the configuration. And then delimiter is another string that maps here. We support a number of different things you can do here. You can, for example, provide validations using Java Bean validations. We also allow you to create nested classes and even lists within there, so you can make a more complicated configuration structure if you want. You can give default values, and it's actually even possible to make your plugins pluggable. We do that with the aggregate processor, and I'll mention that a little bit later. One other thing you should know if you're developing a plugin is the basic concept of an event. All data flowing through Data Prepper goes into this event model. And the event model you can think of as being a JSON-like structure, a map, dictionary, whatever model you want to fit in there. And we have a syntax that we use, JSON pointer, to express how we get data in, or how we can put data into events or extract it out. So in this case, request data tells us we can get that whole request data object. But if we want to get the request data method and get that put string, we can express it with this request data / method syntax. And that will allow us to get that. So Data Prepper Core provides all these capabilities for us. So you just have to use the basic event model, and then it'll all work for you. All right, let's talk about how you can write a source. So let's say we have a new data source we want to connect to. It could be something like Kafka, which again we already support, maybe RabbitMQ. There are a number of different sources that we could support here. And so creating any source really is about getting data out of that source, right? And so if it's a pull-based source, we always start by going out to that source, requesting data, and then data flow comes from that source. If you're writing a push-based source, you're probably going to spin up a server, and then data flow is really initiated by the external source. So it'd be a slightly different approach. For either push or pull, though, your goal is going to be the same. You get the data in, you decode it, you create a Data Prepper event, and then you put that data on the buffer. Once you've put the data on the buffer, your responsibility as a source author is complete. One other thing you need to be sure to do, though, is acknowledge it with that external system. So some systems, like Apache Kafka, have a checkpointing mechanism. And you'll want to let that source know that you've read the data so you don't read it again. Now, if you're a source author, you want to be aware of a few things. One is that you need to be responsible for your own threads. When Data Prepper starts, it's going to call your source and say, hey, source, start up. And you need to take care of your threads. Maybe you're creating a thread pool for a server, or perhaps you're going to spin up a few worker threads that are reading. Whatever it is, we leave it up to the source authors to define that. Second thing is you're responsible for interactions with that external system. And I think that's kind of the fun part. One of our goals is actually to make it really easy to write plugins so that what you're really thinking about is, hey, how do I interact with this system? Not so much, what do I need to do with Data Prepper? And that's why we try to make the event model simple and also providing you those options for creating configurations. Now, if you are writing a new source, I also really encourage you to support end-to-end acknowledgements. End-to-end acknowledgements allow us to notify the source that we actually wrote the data after it's written to the final destination sinks. I'm not going to go too much into detail about how that works, but there is a great blog post that my colleague Krishna Kandaka and I wrote back in the summer of 2023. So if you want to learn about how Data Prepper end-to-end acknowledgements works internally, I recommend you read that post. So if you are supporting end-to-end acknowledgements, we're going to have the same startup, retrieve, and data flow. We still create events. We write them to the buffer. The difference, though, is now we're not going to acknowledge. We're going to wait for the acknowledgement set manager to let us know those events have been written. And it actually takes care of all the heavy lifting of finding out that all of the events in any given batch did make it to the sinks. And once that's done, it's going to acknowledge back with the source. And now you go back to that external system. I mentioned earlier that Data Prepper has a number of processors that we already have for supporting enrichment of your data, mutations on your data, whatever transformations you need. You can do filtering. But there are certainly times where we don't support what you need. And in those cases, I think you have the option now to write a processor and contribute that back to the community. Processors work in a chain where all the data flowing through your pipeline goes from one processor to the next, each one having its opportunity to mutate the data so that you get it in the form you need to get to OpenSearch. If you're writing a processor, the basic model you have is quite simple. You create this processor, and it implements an interface that takes a collection of events. So you're going to get all those events in, and then you have a chance to mutate those events as you see fit, and then you output those events. This ability to output events also gives us the option to perhaps have other forms of processors. So you can get a collection of events, and perhaps rather than sending those events out, you provide a subset. Or perhaps you create a brand new event, an aggregation on the other events. And so you as the processor author have that option, and you have that ability to control that. If you are writing a processor, one really important thing you should be aware of is that we do have a concurrency model within Data Prepper. Data Prepper will run multiple process workers, and so all these process threads are working, or all these processors are working on different threads. And so if you are keeping any sort of state in your processor, you should be sure to account for the multi-threaded nature of Data Prepper. Now, if all you're doing is taking an event, modifying it, and then pushing it back out, this is already taken care of for you because any event only goes through one thread. So you don't have to worry about it too much. But if you do have any form of aggregation, that's where it's going to come into play. You want to be sure you return your events. That's what allows them to go further downstream. And then I also really encourage you to support error handling. So one of our main mechanisms for error handling is we have the ability to tag events. And so you can add a tag to an event that the user can customize. And so when it goes to OpenSearch, they'll have these tags that say, maybe for example, we weren't able to locate an IP address on this. One other thing I do want to mention is that Data Prepper does support aggregations through a single processor called the aggregate processor. This processor takes care of a lot of the heavy lifting and complicated work for managing your events coming through different threads. And then you can actually plug into that. So it's a pluggable processor, and you can write customized logic for aggregations and contribute it there rather than have to worry about how do I deal with aggregations. And that'll work for a lot of different aggregation use cases. I went over the basics of code contributions. Let's go a little bit into the process. Being an open source project, it's kind of the Wild West in some ways. We're not going to turn you away for not following this. But I do think if you do this, this will probably help you interact with the community best. First of all, anything starts with an idea or some sort of business need. Why do I need a new source? Why do I need a new processor? I would definitely encourage you to think about those things and then create a GitHub issue on it. Creating a GitHub issue helps in a few ways. One, you can get feedback on the concept itself, We can give you some early feedback so that we don't have to give it later in the PR. The other thing is sometimes there's already an existing solution, and so maybe we can provide another solution. Maybe it's not as straightforward, but it offers you something and you don't have to make that contribution. Now, of course, we get to the fun part of writing code and creating a PR. Once you have your PR, though, you should expect to get some feedback. We like to keep the quality bar high to make sure that the community gets good working features. And personally, I actually really like creating PRs into the open source world. You know, when you create code reviews within your company, you are often working with the same team and you're getting feedback from the same set of people. I think it's a great opportunity to get feedback from a different group that you're normally not working with, and also get some of their expertise on the system. So I think the feedback cycle is great. You should probably expect to get some requests on your PR for us to make, for you to make some changes in that PR. After we've gone through the feedback cycle, we'll approve it, and then the maintainers will merge it in. We merge it into main, and then we also release off of the main branch. We tend to release maybe every month or 2 months. So you'll expect to see that available out to the broader community, probably in about 2 months. I know not everyone is a developer, and not everyone has time to contribute new sources or other plugins to code. But there are a number of great ways you can still contribute and help the broader community. One great way is through documentation. We've actually had a number of GitHub issues created where people come and they ask questions, and they thought maybe something wasn't working or that something wasn't available, and it turns out it was just a documentation gap. And a lot of people in the community have been really great about going and making those updates into the documentation repo itself, and that gets that information back out to the community so that someone else doesn't have to go through the same trouble that they did. All of the data prepper documentation is part of the documentation website repository. It's where we have the OpenSearch documentation and all the other documentation for the project. So if you'd like to contribute to documentation, you can go there and make PRs for the data prepper docs. We definitely welcome bug requests. We like to hear about bugs that we hit because we want to make the product all the more solid. And then, of course, feature requests, even if you don't plan to implement it, are really helpful. It gives us a sense of what people are looking for in the community, and maybe there's someone else out there who would like to help contribute. I hope all of y'all will get a little more involved, and here are a few things you can do. One, you can comment on existing GitHub issues, create new GitHub issues. So feel free to engage with us over GitHub. This is a great way to engage with the maintainers of the project and other contributors. We're regularly looking at our GitHub issues. And so this is a great first step. Now, if you don't know exactly what you want to, or if you don't exactly have like a fully formed thought, or maybe you have just a question, we do have a GitHub discussions page. That's a really good place to go if you have questions. So feel free to reach out to us there. We also take a look at those. We recently started a data prepper triage meeting. We meet every Tuesday at 2:30 p.m. US Central Time, which is 12:30 here in the Pacific Coast. We do a few things in there, but of importance, first we go over the untriaged issues and try to triage those, see where they fit. And then the other thing we do is we leave time open for the community to ask questions, to engage on GitHub issues or PRs. I do want to clarify when we talk about that open forum, though, it's really more geared towards asking questions about contributions into the project. It's not so much about how do I use feature X. So I definitely encourage you to come, and if you have questions about contributions, features that are coming in, or anything related to that, it's a great open forum. We also try to tag some of our GitHub issues with a couple tags that will help inform the community of two things we need. One, there's the help wanted. So we use this tag if it's something that the maintainers probably aren't going to get around to. So if you see something here with help wanted, it's open. Someone in the community could definitely take a look and make that contribution. Those might be complicated, though. So we also have the good first issue tag. Those are for pretty simple issues that we think someone who's not really familiar with the code can hop in and take care of. And on any of these, again, if you comment, we are really happy as the maintainers and contributors to give you suggestions on how to go about it. We actually had one recent contribution, for example, where someone added a new Kafka authentication mechanism. And in order to help the teammate out, or the community member out, I gave a number of suggestions in the code on where to start and how to look. And so we're really happy to take in your contributions. And I think with that, I'm mostly done. I do want to say that, again, with sources, processors, and really even seeks, if you're interested, there's a lot of opportunity here in Data Prepper. And I do encourage all of you to contribute, to join in our forums, engage with the community some more. Thank you so much for coming and listening. And that's all I have for today. If we do have time for questions, I can hang out here. And if not, I will be available after the conference. Good.